Hello, welcome to the second lesson of Intermediate Java. Today we're going to be talking about arrays. Start off with a review of what we already know about arrays. We know that we can create an array with the following format, right? It requires the data type and the length of the array for it to work. We type the data type and then brackets to show that the variable is an array. Then the name, and then equals, and on the right side of the equal sign, you want a new is a keyword that's going to tell the computer to create a whole new array, or whatever you're putting after that. It's going to create something new in memory. That's what the word new does. And then you want to say the data type again, and then in brackets, you want to put the length. And this example right here is creating an integer array called name with length. Some properties of arrays are that they are immutable, which means you can't change their size, right? For example, this array that has a size of 3 is going to stay at size 3 forever. You can't change that. But if we wanted to add a number to this array, a fourth element, we could do that by creating a second array that has a length that's one more, and then copying the values over, and then we'd have this extra value which we could store whatever our fourth element is into. One thing that's important to know with arrays is sorting an array. There are a lot of ways to sort an array. The simplest way, in my opinion, is selection sort. The way you think about it is you just find, okay, what's the smallest element? Okay, it's that one. Put that one at the front. What's the second smallest element? It's that one. Put that one second. And then you keep going for the third and the fourth and the fifth all the way to the end. And then it's in order. So this is an illustration of selection sort. So we're trying to find the minimum number here. So it's going to do the minimum algorithm. So it's going to say, okay, 17. Okay, that's less than 21. Oh, it's not less than 9. 9's our new number. And then 1. Okay, 1's the smallest. So it's going to go at the front. We swap it with the first. And then we find the next smallest, 9. We swap it with the second. Then you find the next smallest, it's 17. We swap it with the third. And then it's done. I can show you a more animated example here. So we have this array, 3, 7, 16, 1, 9. Okay, we find the smallest one. It's 1. Okay, we put that at the front. So I'm just going to rewrite the array. So 1, 7, 6, 7, 16, 1, 7, 16, 3, 9. Notice we swapped the 1 and 3. Okay, then we stop looking at the first element. Now we're on the second one. Okay, what's the smallest? 3? Okay, so we swap 3 and whatever's at the second element, which happens to be 7. Okay, now we find the next smallest. It's 7. So we're going to go 1, 3, 7, 16, 9. We swap the 7 and the 16 because 16 is in the spot where the 7 should be. Then we find the next smallest. Out of these two, we find the smallest. It's 9, so we swap it with whatever's in the fourth slot, which happens to be 16. And then we've got to the end. We're done. This is sorted now. That's basically how it works. There are some other little algorithms with arrays that you might want to know how they work. You don't actually really need to use them, because if you want to be adding and removing things to arrays, you're going to be using array lists anyway, and those are like way easier to work with. But it's good to know how this works at least once. It's okay if you forget it later. So if you want to add an element to the end of an array, you just make a new array that's a size of 1 more than the original one, and then using some loop, you would copy each element from the original array over, and then you'd have 1 extra slot at the end, and then you would add whatever your new element is to that slot. Pretty straightforward. Removing an element is slightly more complicated. So, as you might have guessed, you create an array that's a size of 1 less than our previous array. And then you have two parts to the copying. You copy all the values before the array just like normal, right? The 0 goes to the 0, the 1 goes to the 1. But then you have to copy all of the elements after the array. So we have, not the array, after the value that we're trying to remove. So we want to remove our 20, and that's at the second slot, right? So we copy the 0 to the 0, the 0th index to the 0th index, the first index to the first index, and then we have to skip the second index here and start on the third index, right? So wherever our element we're trying to remove, we skip over that, and then we go to the next, we continue going through with the rest of it. Now notice that this 27 is at index 3, but we want to put it in index 2 of our original array, of our new array, not our original. Now, this means that you can't do it the same way that you did this 17 and 18, right? You just did like, for each in this, put the I from here into this one's I, basically, right? You would have the index at I. Here, our indices are different, so we have to do some either addition or subtraction here inside of our for loop. Like, we have to say I minus 1 or I plus 1 inside of our index in order to compensate for this difference. This is the main part that's confusing. Alright, now one last thing is combining two arrays. The way we would do this is you make a new array that's its length is equal to the sum of both sides, of both sizes of the other arrays, right? And then you just copy the elements from the first array over, pretty straightforward, and then you copy elements from the second array over. Now, the thing is, if I go back to this whiteboard, if I have two arrays, 1, 2, 3, 4, 1, 2, 3, 4. Let's just say there are some random values in here, and then we have an array that has 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Alright. So what we would do is we would copy, so this is our 0, 1, 2, 3. 0, 1, 2, 3. Those are the indices. These indices here go all the way to 7. Now, if we want to we basically want to put these two arrays together. We just want to push them together, right? So we copy the elements over from the first one, I'll call it the first one, onto the big one. So we go, okay, copy the 0th one onto the 0th one, the first one onto the first one, the second one onto the second one, the third one onto the third one. Then we need to go to the second one and continue copying. Now, you can't do it the exact same way that you did the first one. You can't go copy the 0th one onto the 0th one and the first one onto the first one, because then you're going to be rewriting, right? So if this was 1, 2, 3, 4, 5, 6, 7, 8, right? You'd copy this 1 here, 2 here, 3 here, 4 here. Now, you need to make sure that your index is compensated for here, right? If you just say, oh, copy each one to its corresponding index, you'd be copying the 5 over to here, but we don't want to do that because our 1's already here. We don't want to rewrite that. So instead, you have to make sure that you're somehow adding to the index that's pointing on the big one. So you could add the length of the first one. So if you're at 0, right? So you copy the 0th one from I, and then you copy the 0 plus this length one from I, and the length is 4, so it would be the 4th one. You could do that. You could also have some variable at the very beginning that it only keeps track of this big one's index, and you just add 1 to it every time you copy a value over. That works too. But it's important that you know that you have to compensate for this index being different. Alright. And that is it. The 4 exercises for this lesson are, first one is write a program that finds the minimum number of an array. And then the second one, you need to know how to do the first one in order to do. So after you found that minimum number, then write a program that's going to remove that number from the array. Then the third and fourth exercises are write a program that sorts an array from smallest to largest. Try using selection sort for this one. If you did the first exercise, then you already know how to find the minimum number, and that's basically what selection sort is. It's finding the minimum over and over again. Then there's a challenge. Given an array that's already sorted, like this one right here, write a program that adds an element to that array in its correct spot so that you don't mess up the sort of the array. So you take, if you wanted to put a 3 into this array, it would have to go between this 2 and 5. So you'd make a separate one that has a length of 6, one greater than this, and then you would have to put this 3 in the right spot so that it's in between this 2 and the 5. And that's it.